Okay, let's do 8.1 homework 22, logarithms. I'm going to make an assumption that you've seen the other videos, the earlier ones about the properties of logarithms. Those are really important because we're going to be using all of those. And if you can just keep those rules in mind, you should be okay. All right. I'm actually finished with this unit, but I'm going to do it from scratch because why not? Okay, so let's get started. All right. So this is simply one of those problems where you rewrite the exponential expression on the left to its equivalent logarithm expression. You see that 4 to the 5th power is 1024. Now remember that the question that a logarithm is asking, if 4 to the 5th power is 1024, then I'm asking the question, 1024, I don't know why I did that, log base 4, I'm asking of 1024, what exponent do I need to give the 4 to make that number? And that's 5. So we just rearrange these, and you keep the same structure all the way through. So if you look at the structure, A corresponds to 1024. So we're going to put that in and put it here. So 1024, and this is going to be 5. Same thing happens here. So the number that we're trying to reach is 0.001, and we get there by using an exponent of -3. Just rewriting that problem. And we get that right. Really easy, but you do need to practice possibly. Next question is similar to that. Not a whole lot of difference. The same kind of idea. Rewriting now the logarithm backwards. And we know that 2 to the a power, literally the power being 5, gives you 32. And we're done with that particular problem. Going to the next one. Looks like 5 and 5 are the exponents. So the exponent here is 5, and the result is 3125. 5 to the 5th power is 3125. Hit it. We didn't have to write anything. I hope you're noticing that because it's that easy. Number 2. Same thing again, but they want us to put everything in here. So log base 4 of 2 equals 1/2. In other words, 4 to the 1/2 power is 2. So we're going to keep that in mind. So this is 4. This is 1 over 2. I'm going to get rid of that equation there because I don't like it. And we know the 2 is going to go here. Again, stating this one more time, 2 to the -5 is 1 over 32. So 2 to the -5 is 1 over 32. If you just restate it in your head, it becomes a little easier to do. Easy questions. These are not really hard. And we're already at question number 4. Again, same thing. They just keep repeating these questions at us, and I don't like that, but okay. Log base 5 of 25 equals 2. 5 to the 2nd power gives us 25. So 25 will go here, and 2 will go there. And if you just follow that structure, right, notice that they just reversed it here. They're trying to trip you up. But the same kind of thing. This is 36, and 6 to the 2nd power is 36. And then this is like the first one, letter A. So we know that 1,000 is the intended number, and the exponent that's going to get us there with the base of 10 is 3. And then lastly, same thing, they reversed it. So this is like B. I don't know why they feel like they need to do that, but it's okay. We know that this is going to be our target, 0.0001, and the exponent that's going to get us there is a -4. Hit it, and we're okay. I hope this makes sense to you because it's really easy, but once you get into a way of thinking about the problem that makes sense for you, you should have no problems. Now we go for the crazy ones. These are really annoying. I can't really say I'm fond of them really, but they are part of the problem set, so we do have to deal with them. And these are the values that you have to watch out for. You have to rearrange these parts in such a way that you get a lot of A, a lot of B, and a lot of C, and then replace them with 2, 3, and 5. And using all the rules, especially the power rule, the quotient rule, the product rule, the idea that the square root of a number is the same thing as that number to the raise to the 1/2 exponent, all those things are coming to play here. Okay, so if you just remember that you know everything you need to know, you should be okay. Okay, so taking the first one, ln of a to the -4 power. Okay, so let's take the ln of a to the negative 4 over b to the negative 1 c to the fourth. This is something I'd like to do. I'd rather deal with the positive exponent rather than negative exponent. So I'm going to reverse these. Remember that any number raised to the negative 1 power is simply that number under n, under the fraction. You know, reciprocal it. You can kind of think of it as rearranging these to make a fraction. And I'm going to do that with these. And that's going to mean that this is actually the same thing as if I were to say ln of, okay, well, you see the b to the negative 1? That's going to make it flip up to the top, and the a to the negative 4 will make it drop down to the bottom, and the c to the fourth is there anyway. It just seems easier to me to do it this way, and it should work. We're going to try it out. Now, remember that this is a quotient rule as well as a product rule, and so that we're going to have a subtraction as well as two additions. That's going to translate to ln of b minus, because the other two are being divided, ln of a to the fourth, and a minus again, ln of c to the fourth. Okay, if you group them together, you still get the parentheses and you still have to distribute. This is what you would get. And we now have to use the power rule for both of the fours. So ln of b minus 4 ln of a minus 4 ln of c is your next step. And you know what, now that I'm looking at this, I might want to take out the 4, right? That it's happening in both places here. So I'm going to do ln of b minus 4 and divide everything by that negative 4 divided by the 4. That's going to give you ln of a plus the ln of c. Because if you divide that value out, think about what happens when you multiply. Negative 4 times ln a is negative 4 ln a. But negative 4 times ln of c is the one that's going to give you negative 4 ln c. So keep your signs straight. You should be okay. If you don't feel like this is going to work for you, then go back to this one. You got the same answer either way. Now, you'll notice that we have ln b. We have everything we need here. Ln of b is 3 minus 4 times ln of a is 2 plus 5, which is 7. This is 3 minus 28. So that means that our first answer should be a negative 25. The good thing I like about doing these videos is that you can play this back. If this gets anywhere confusing, you can just follow at your own speed. I'm going to pop this one in. Negative 25 is what we should get. Oh, what did I get wrong here? What did I do? What? I don't get it. What did I do? It's the same thing. What are you telling me? I don't know why it's telling me I'm wrong when oh, I didn't answer everything. Okay, I'm not wrong. I just didn't answer all the questions, and it wanted me to answer everything at the same time. So you can take that to the bank. This is correct. Now, the same thing is going to happen here. So we're going to have to use the idea that the square root sign and the exponent of 1/2 are in fact the same thing to solve this problem. So we're going to write the ln of this, right? This whole mess here. C to the 1, a to the second power. And rewrite it, because we know that is the same thing as the ln of b to the fourth, c to the first, a squared to the 1/2 power. And that's going to be much easier. Now, one thing I would say you want to do is think of this as distributive property. I'm going to take every exponent in and multiply it with this half exponent that's out. So ln of b to the fourth power, 4 divided by 2 is 2, okay? Plus the ln of c, using the same idea, 1 times 1/2 is 1/2, and that's going to give me the third one, which is a, and 2 times 1/2, half of 2 is 1, so that's pretty much all you have there. And, oh, I left out the ln, sorry about that, that could leave a mistake here. Now we need the power rule. 2 ln of b plus 1/2 ln of c plus the ln of a. Now we're going to replace the values. 2 times 3 plus 1/2 of 5 plus 2 is our answer. I'm going to do this one and this one. That's 6 and 2. That's going to give you 8 plus half of 5 is 2.5. That's going to give me 10.5. A calculator does help, but again, you don't really need it. I'm going to pop it in here without submitting this time because I know it didn't like that the last time. Okay. So far, so good. Take a pause if you need to. And I'm moving on to the letter C. Same thing. You're using the entire thing. So we're going to hit it. I recommend you do the numerator first and then a denominator second. Think of these just separately. So ln of a to the first b squared is the same thing as ln of a to the first plus ln of b squared, which is equal to ln of a plus 2 ln of b. And that whole thing will resolve down to 2 plus 2 times 3. 2 plus 6, which is going to give you 8. And I would hold on to that for right now. Okay, that's all I would do here. And then the second thing I would do is the denominator. So I'm going to change the color for the denominator just to make it visually separate. I'm going to take the ln of, what is that mess? Okay, big parentheses, inside the big parentheses, a small parentheses, bc to the negative 2. Okay, so that's going to resolve to, let's see, do that distributive property thing I told you before. Ln of b to the negative 2 plus ln of c to the negative 2, and power rule it. Negative 2 ln of b minus 2 ln of c. Remember that the 2's will come out, or negative 2 will come out, whatever you want to think of it as. But just remember that negative 2 times ln of b is what you want here. And you want negative 2 to multiply with a ln of c, because negative times this will give you a negative 2 ln c. Now you're ready to resolve this. Negative 2, what is it? 3 plus 5. Okay, that's 8. Negative 2 times 8 is negative 16. That's everything, I guess. So, oh, wait. Yeah, that's it. Okay, so now we have 8 over negative 16. And we all know that 8 over a negative 16 is equal to a negative 1/2. So I believe that's what we need to put here. And for the reasons that I'm outlining, I think it makes sense. In case it doesn't, please feel free to play this video back. 1/2. And we're now ready for the last one. And this is, at this point, if you've done these enough, these become a little bit easier. And again, I would take these separately. So I would take each part, resolve each part, and do each part separately. So go back to black. The ln of c to the negative 4th power is equal to negative 4 ln of c, which is equal to negative 4 times 5, which is equal to a negative 20. We're going to hold that number. We're not going to use that number until we're ready for the other piece, which we're going to do now. Ln of a over b squared, and that whole thing is squaring. Okay, so we're going to ignore this right now. We're just going to take care of what's inside. That's the ln of a minus 2 ln of b. I'm just folding in that power rule into the solution so far, and that's going to be squaring. We have everything we need at this point. Ln of a is, as before, 2 minus 2 times 3, and we're going to square that result. All right, so we're going to get 2 minus 6, and we're going to square that result. That's going to give us a negative 4 squared, but a negative 4 squared is a positive 16. So we have our second part now, and we have to multiply these together. We're going to do that now. That's going to give us negative, oops, sorry, I don't like that marker thing. I forgot it's there. That's going to give us a, what is it? A negative 20 times a positive 16. That's a negative 320. That's what I'm going to put down for my final box. These are really, like, I don't know how to explain. They take work, and they're kind of like drudgery, but they're not hard at the same time. And if you try them a couple times, you should find them easier as you get along. All right, I think I'm ready to input my submit. Okay, it looks like I got Oh, it has a negative 25. My bad. Remember that first one was negative? Submit one more time. And now we're okay. So minor issues, just keep track of all your values. Make sure you use your power rule, your quotient rule, your product rules. You should be okay. We're up to number 6. Number 6 says, okay, this is asking us to use the quotient rule to squeeze this into one giant term, or one compressed term. Well, we know that's log base 7, so we're going to have log base 7 no matter what we do. Log base 7, and I'll go back to this. Log base 7 of what? Well, it's 8x, right, minus 11x squared right here. That's division. So I'm going to turn that into a division. 8x over 11x squared. But don't input this because this is not complete. You have to clear the x's. Log base 7, if you divide out, you're going to see that it's actually 8 over 11x. That's what we're looking for, but it also wants that too. So make sure you give it the log base 7. Don't just fly into that. So you're going to do log base 7 of parentheses 8 over 11x. Oops, be careful with that too. No, it won't let me do it, so I'm going to have to put parentheses on it. 11x, and now it takes it the right way. Okay, so I think we're ready to... What did I just do? I don't get it. Let's see. 8 over 11x. I honestly, I'm not sure. Yes, I know it's not matching parentheses. I'm trying to match it, and you give me trouble. Oh, I see. There should be 2. Okay, so now we're okay. And we're done. That's all we have to do here. Hit submit. We got that right. We're already up to 7. It's really quick. This is asking us to do the opposite. It's asking us to take the, in this case, product rule and create an addition problem of logarithms with no exponents and no radicals. And we have to get rid of the exponents and radicals. So we're going to take this and apply each one. We're going to split this up. That's going to require that we keep in mind the reverse of the product rule. These are multiplying together, means that when I use the product rule, they're going to be adding together. Log base 5 of x cubed plus log base 5 of this terrible thing here. Okay, and we just have to convert this. So that's going to turn into the same thing as y to the 11 divided by the index of 5. So that becomes that. So now you have what you need to do. We're going to power rule this right away. 3 log base 5 of x plus this. And we're going to power rule that too, because, you know, it would have been here anyway, right? It would have been like y to the 11 over 5. And we're just going to power rule that thing and put in the piece that we need to have there. That's going to give us a 11 over 5 log base 5 y. And that's the entire thing. But that does mean we have to put that in. So we're going to do all of that. 3 log base 5 of x, okay, plus 11 over 5 log base 5 of y. Okay, I think it has everything we need. I think it's all there. Let me just make sure. It looks in order. It looks like what we just came up with prior. I'm just going to bring that screen back so we can take a look at it. It looks like it's correct. I think we're ready to submit. Let's put it in. And we got that right. We're down. Oh, that is the last question. So I hope that this unit helps. I'm going to be uploading it. And I wish you luck with it. If you have any particular questions that are really grinding you, just let me know and I will help you out. I'll talk to you.